grade 10s, we're on page 413. So, grade 10, today we have to put our thinking caps on a lot more than we did yesterday. So, let's get going. Page 413. So yesterday we just introduced our ideas behind relations. Workbook's open, pages there, guys. So a relation is a connection between two quantities. It can be represented. It can be represented as a set of ordered pairs. The first component of the ordered pair is always our x coordinates, also known as our input, also known as the independent variable. I need to write that in. Our second component of our ordered pairs is our y coordinate, also known as the output, and it is the dependent variable. Yes, Sandy. Yes. Yes. Always. Yeah. Okay, so today we're doing lessons 3 and 4 today. So lesson 3 is always talking about, or it's mostly talking about our x and y intercepts. So this is what I briefly mentioned to you yesterday, but we're going to go a lot more in depth into them. So if we look, we are given 3 graphs here below. Graph 1, graph 2, graph 3. So graph 1, what are the coordinates where it crosses our x-axis? Go ahead, Charlotte. Good. Graph 2, it crosses our x-axis in 2 spots. What is one of those spots? What are one of the coordinates? Go ahead, Krista. Good, -2 and 0. And the other coordinate is? Go ahead. 3 and 0. Remember, this shape is called a parabola. Just so we're using our correct terminology. Graph 3 crosses at 2 places as well. So at -4 and 0 and +4 and 0. What is common between every single set of coordinates that we just wrote down? Good. Our y is always 0. Right? And like, let's think about that realistically and like practically for a second. In order for it to cross our y-axis, there's no height. It's not up or down at all, right? It's at neutral, it's at 0. So our rule then is our y-intercept, sorry, our x-intercept y is equal to 0. That's the only way it can cross our y-axis. My apologies, I said that wrong. It's the only way it'll cross our x-axis. So our x-intercept is where the graph crosses the x-axis. Okay, going back to those same graphs, let's look at where it crosses our y-axis. So graph 1 crosses it at 0 and 5. Graph 2 crosses it, I think that's at 6, 0 and 6. And graph 3 crosses at 2 points, 0 and -4, and 0 and +4. What is common with all of those? Go ahead, Carissa.
The y-intercept is where the y-intercept is x.
Good. We always have zeros there. So it's like backwards, but it makes sense why it's backwards. So our y-intercept, sorry guys. Is where x is equal to 0, and that's where the graph crosses the y-axis. Let's just go through and maybe label it a little bit better on the actual graphs. Try and zoom in as much as I can. So this is our x-intercept, y-intercept. So you can have multiple intercepts, both of x and y. Most often you'll see multiple x's and only ever one y-intercept, but you can. So graph 3 shows where you can have 2 y-intercepts. And there's 2 x-intercepts. This will have lots of questions on solving and finding your x and y intercepts from here. Can I turn the page? Are you guys okay? Okay. So this is them writing it out. I think it's easier. Like personally, I would always rather read my handwriting than their textbooks. But our x-intercept is where the graph intercepts our x-axis. Y-coordinate is 0. Y-intercept is where it crosses our y-axis. X-coordinate is 0. So using that, we can solve for where it crosses your axes and what those different points are at. So let's go through an example. So graph 1, sorry, did you guys want to see where I have circled? The first graph is this equation. You most often won't ever see it in that format, and we're going to get into that later on. So we're going to use the format that we're more used to of this y equals 5/3 x plus 5. Your workbook just goes in a different order than I'm teaching it is all. So if our equation for that graph 1 is y equals 5/3 x plus 5, and the question's asking solve for your x-intercept, all you're going to do is plug in 0 for y. And then we can solve for x. So when I do that, I'm going to get 0 equals 5/3 x plus 5. How do I isolate and solve for x? Go ahead, Andy. Oh, sorry. Good. So we're going to subtract 5 from both sides. I have to isolate that variable, so I'm going to minus 5 from both sides. So then I get -5 equals 5/3x. What's my next step? Good. Times both sides by 3. So those two cancel out. So then I have -15 equals 5x. Last step, divide both sides by 5. So then I get -3 equals x. So our x-intercept, what the question is fully asking for, is at -3 and 0. So if we are solving for our y-intercept, it's slightly different. What do we do to solve for y then? Good. We're going to plug in 0 for x. So same equation, because we're still talking about our first graph. So we have y equals 5/3x plus 5. So instead of writing x, I'm going to write a 0. Anything times 0 is 0. 0 plus 5 is 5. You will learn later on, but I'm going to tell you this right now because it just makes life way easier. Whenever your equation is in the format y equals everything else, the last term is going to be your y-intercept as well. That's like our next unit. So when it's in that format, whatever it's like adding or subtracting at the end is your y-intercept as well. So your y-intercept is easier to solve for. Go ahead. Well, 5 over 3 times 0 is 0. Okay? Yeah? Okay, so the second graph was x squared plus y squared equals 16. That's the equation of our second graph. You can write that equation in a lot of different ways, but we're going to use like this format because that's the format they've given us. So to solve for our x-intercept, we plug in y. So I'm going to get x squared plus 0 squared equals 16. What is 0 squared? Good, so I get x squared plus 0 equals 16. Do I need to write that line down? No. Sorry, Andy, go ahead. Plug in 0 for y. My in's really close. That's okay. How do I get an x out of an x squared? How do I cancel out the squaring? Good. So remember back in grade 8 when you first learned about square roots, it's always actually the positive and negative, right? So the square root of 16, often we just say is 4, but it's actually positive 4 and negative 4. Because positive 4 times positive 4 gives us 16, but negative 4 times negative 4 also gives you 16. So our coordinates here for our x-intercept, this is the one where we had 2, because I can have positive 4 and 0 and negative 4 and 0. And that's why we were able to have 2 in that parabola shape, because there's that squared in the equation. You have to write both, because it crossed our graph literally twice. Kind of tricky when you think about that, though, and hard to remember sometimes. Well, like, remember, like, flip the page over. Our graph was like this, right? So it literally crossed that x-axis twice. So that's your prompt to know that there's 2. But whenever there's you take the square root of something, you actually have 2 answers. Yeah. So you'll either have the graph given to you, like in this question, or you would plug it into your calculator, and then you would see it as well. I will show you how to graph on your calculator in another class. Go ahead, Andy. Okay, so for our y-intercept, we had, so x squared plus y squared equals 16. Oh, my apologies, this is graph 3. We started with graph 2. So our y-intercept, we plug in 0 for x. So then I get 0 squared plus y squared equals 16. This is like bonus step to show when I square root it. We're going to get that same answer of y equaling positive and negative 4. But now, because our x coordinate is 0, it's that way. This graph, my apologies, was the circle graph. Go ahead, Andy.
So on the graph, the other four, the coordinates were like 3 and 4, you wouldn't plug in 0, just plug in 3 and 4.
Yeah, but because you're just finding like a data point at that point. We're specifically looking where it crosses an axis here. So that's why we're plugging in 0. Yeah, that's a really good clarification. Okay, turn the page. So we're going to go over a question where it's talking about like an application of this. A lot of this unit is talking about the application in pieces. So Lisa's purchasing a new car for $20,000. value of the car is represented by this formula, 20,000 minus 1,250 T. Then it tells us V is the value of the car in dollars, and T is the age of the car in years, right? Your car depreciates in value. Often is a combination, but of years and how much, like the mileage, how many miles have driven on it. So they are not including mileage here. But this is their equation here. So we know when we buy the vehicle initially at 0 years, when we first buy it, it's worth $20,000. So we know we're gonna have a data point right there. That is your y-intercept. So that's question B. That's when our car is brand new. There will be a point in time when the car has no like theoretical value anymore, right? When people might argue that that's when your car is like it's worth the most to you, right? Like you can't resell it, so you're driving it into the ground kind of thing because you've used all the value of the car. So we can calculate and figure that out. When you're drawing this graph, I'm going to just give you this data here so you don't have to calculate it. So this is going to be 20,000. After 2 years, so we could plug in 2 for our T, it's going to depreciate down to 17,500. After 4 years, it depreciates down to 15,000. After 6 years, it depreciates down to 12,500. So we can plot those points on our graph. Oh, good, they did draw it out for you. So at 2, we're going to have a data point right here. 4. Are those forming a nice straight line? Yeah, so this is a linear relation. If you continue with this trend, you might be able to do this better on paper, but I'm really bad at it on the computer. But if you continue this trend, you can see when it's going to cross our x-axis. My line is not straight. It will cross your x-axis at 16 years. So they've worded as your t-intercept because my x is represented by t here, but really that's our x-axis, right? So at 16 and 0, that's when the car has no value anymore. So after 16 years, me as the owner, though, would it have value to me? Totally, it's still my car. It's still a drivable car. It still gets me from point A to point B, but I wouldn't be able to sell it for anything, really. Go ahead, Andy. It's a very straight line. Mine does not look straight, but it would be very straight. Yeah, because it like every day within the year, in theory, it would decrease. Yes, I see what you mean. So it's a continuous line. Yes. So let's estimate. Let's just do 10 years. So if I go to my 10-year mark, it's going to be about right there. So let's plug in. My line is not very straight. Pretend my line's straight. So if I was to verify what this is, we're going to plug in 10. So I have B equals 20,000 minus 12, was it 1,250? Times 10. By all means, you can use your calculator here. We should be getting answer of 750. Sorry, 7,050. So my graph is clearly not very straight. It should be right here. I'm a little bit off. On the flip side, we can use the graph to figure out when it's so much money. So say I want to sell my car when it's worth $5,000. I can go horizontally and see what my vertical is. To see after how many years my car will only be worth $5,000. Using my formula, I have to plug it in to the V side then. So then I would have 5,000 is equal to 20,000 minus 1,250 T. What's my first step now in isolating? Head and tail? No. You have to, this is where it gets a little bit tricky. You have to cancel out your constant first or your term without the variable. So the 20,000 you actually have to get rid of first. But it's written first, so it's not as leading. So I'm going to subtract 20,000. So then I get, don't forget to rewrite that negative or that subtraction sign, so then I get negative 15,000. Now I can do my division. And I get 12. So I'm dividing both sides by a negative, so that's why I can get that positive 12 years. Does that make sense? Is that okay? Okay. So that's lesson 3. We're going to start lesson 4 as well. So I want you to take a second and write down like what practice questions I want you to do. Sorry, some of you aren't done and I don't remember them. There's not a lot I'm going to get you to do. At the end of the day, this is like algebra, plugging in 0 or plugging in values. So number 3 and number 5, but you only have to do A, C, and that's an L for number 3. So if you could go through and circle those right now, that'd be great. I mean I. So not a lot here. Okay, and then turn to lesson 4. So our x-intercept has a y-coordinate of 0. Our y-intercept has an x-coordinate of 0. So they're backwards. Domain and range. This is the stuff that's like weird and very much like mathematicians decided it, and this is what we do. So it's a lot of notation with this next portion. So domain and range. We started talking about these yesterday. So our domain is all the values of our input, or all the values of x. Our range is all our values of our output, or our y. So we're going to do a quick little itty bitty sketch just to the side here. So if I was drawing a graph that was like this. So discrete data, just like that. Let's label this 0, and let's say this is 10. And the maximum, like the hill in my little graph here, is at 6. Your domain is simply like my horizontal values. So my domain here is just from 0 to 10. So it's just talking about like giving context. It's like the words you use if you were talking to like another, like your mathematicians and like university profs talking about it, they'd be like, the domain of this stuff is from 0 to 10. This is the range of values on my x. Versus my range specifically here is only from this point to this point here, right? Like there's not values that go below that. So that's our range, or the y values, the vertical portion of it. So it's just talking about those two different ways to like discuss and talk about your graph. and values within your graph. There are very different ways that you can write this out. So if you turn to class example 5, we're going to fill in some notes there. This is just like, I don't like how your workbook sets it up. No. Our project is like this unit and our next unit together. So yes. So write relatively small here. So I'm going to fill in a lot of notes. So for discrete data, you're just going to list the values. In specifically the fancier brackets or in parentheses. So what that means is like, you'd be like, my domain, or all of the X values that are included here are 1, 2, and 3. Fancy brackets like that. Your range might only be 7, 8, and 9. Discrete data, super easy to do. I'm never going to give you discrete data that has like a ton of things to write out. So like it'll be like less than 10 kind of thing, data points you would write out. So it's basically your X values and then your Y values. Where it's harder is continuous. And we use a format that seems really wonky, and I'm going to write it out for you first and then explain all the different pieces of it. So you would start with continuous data, your fancy bracket, X, and then a vertical straight line. And then you'd put a number here. So this is less than, that's what those symbols are. So it might be like, we could say -4 and 5. Very specifically, then a comma. And then you write this. Notice how I write my E. It's like a wonky E. And then it's an R that has like 2 backsides to it. I'm going to describe what each one of these components means and how we would say this. But it's like, so we call this is how you describe your domain and range. So for range, instead of writing X's, you would write Y's. Seems really complex. It's the same format every single time you'll write it out, though. So you start with your fancy brackets, or your parentheses. And then it's your X values for domain if you were doing range. This straight line means such that. So at this point, we'd read our X values such that. This next portion, you probably, I don't know if you're, did you guys have Miss Diepolt or Miss Chow last year in grade 9? That was the grade 9 teachers. I don't know if they showed those to you. Your arrows, so this is like less than, equal to, greater than, those are what those arrows are. For like this notation, it's always going to be both arrows pointing to the left. Basically, it means X values between -4 and 5. That portion might change, like it might be always X values greater than 6, or x values less than 2. We will go through lots of examples, but this, both arrows pointing to the left, it just means they're in between. You read it from the x, so you'd read it as really like x values that are greater than or equal to -4, but also x values that are less than or equal to 5. I feel like that's super complicated, and I just think of it as between -4 and 5. This last portion, do you guys remember last year when you learned about whole numbers, natural numbers, real numbers, like the real number system and how we can categorize numbers? So that R at the end means real numbers. So basically we're not including imaginary numbers. That will almost always be the case for us this year. So what we'd say this last portion is X is an element. That's what that E means. Of the real number system. So it's like a line and then an R that are connected. So it could be, if you're only talking about whole numbers, you have the whole number W there then. So it will vary a little bit on that last point, but we'll go through examples. So turn back to the first page now. Go ahead, Andy. Sorry, say that again. What are those? Greater than, less than symbols? Like this is greater than or equal to? Because it's, I'll go through examples and it'll make a little bit more sense. But it's saying like my x values are always between -4 and 5, is what it's saying. Yes. And I'll go through examples and show you what I mean, but I just, this is like how I can do this best here. So on class example 1, the first one, let's just do our domain because the space is really small. So they've listed coordinates for me. If we were to have graphed those coordinates, they're just dots on a graph, correct? So this is discrete data, so we just list it. So you'd be like my domain, you do a fancy bracket, and we're just listing out our values. You always list them smallest to largest. So I have a -3 here. So I'm going to write -3, comma 0, 1, 3, and 5. Close your bracket. Discrete data, super easy. So all we've said here basically is the x values are these. Versus on that one, our range is just your y values. Again, smallest to largest. We have 2 2s, notice, like there's a 2 here and a 2 here. You only write them once, so I can just say it, well, it has a 2, a 5, an 8, and a 9. So all I've done is list x values, list y values. Is that okay? Make sense? Cool. I'm not going to do class example A because there's not a ton of space for the ones below, but we will do B and C. Okay? A, again, is just discrete data, so it would be the same thing. Just write out your x, just write out your y. So let's look at B. I'm just going to make it a little bit easier to see on the board. So this is my y-axis, my x-axis, and my graph. Can someone describe, like in words, what are your possible x values here? But it's a connected line. So it's every single point in there. So it would be like -4, -3.999999, -3.9, -3.8, -3.8777. Like it's every single point in there. Okay, Andy, you try. It's only, this is one of those wonky cases. -5 is actually right here. So -4 and 4, but it's also -1. It's between those. Yeah. So how we would describe this are x values in like casual language. We would say my domain here is every value between -4 and 4. Does that make sense to you guys? Right? Like those are the possible values for x's here. Using our notation, you would do your fancy bracket, our x values, such that they are between -4 and 4. And then x is our element of your real numbers. So it's every single x value between -4 and 4. Oh, thank you. So in like easy terms, every value between -4 and 4. In like correct math language, your x value such that x is between -4 and +4, and x is an element of your real numbers. Our range, who could describe your range for me in like casual words? What's like the restrictions on our range? Do I have negative y values? No. Do I have a y value of 10? No. So my y values, I think that's 4 as well, right? Yeah, because 5 is up here. So my y values are specifically between 0 and +4, and it's every y value within that. So then it's y is an element of the reals. Andy. Equal to, yes. So if it was an open circle, so Andy, you're saying like this line here. So that means equal to. So if it was an open circle at that point, then no, I wouldn't put the line. But since it's a closed circle, that means it includes -4. So it can be equal to -4. So I have to put that line, yes. Charlotte? Sorry, can you say that again? I couldn't quite hear you. Yeah. Yeah. And I think there is an example later on where it's an open circle. So our graph for C is a little bit different. Let me just darken it again. There's arrows at the end of this graph versus before it was a dot. What do arrows mean? Go ahead, Matthew. Good. It continues on forever within that trend. So this, I think, actually makes it easier. So for our domain, that line's going to keep going at a slight angle out and 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 out forever. So in this case, my domain is just an element of the reals. There's no other restriction. I can have every possible x value here because there's a slight angle. So it's going to keep going horizontally out and hit every possible x in theory forever. Much more of a restriction on my y's though. So I have no y values that are greater than 4. It goes much more negative. So we would say all the y values such that y has to be less than or equal to 4, and then y is an element of the reals. So because that's a closed circle at the very top, that's why we have that equal sign underneath. Say this was like an open circle right here, and then like that, we would just say less than 4. But it includes that specific point with it being closed in. Andy? Continuous data, yeah. A is discrete, so A, you would just list it out. the best way to do it. Like technically it is. If you just put an E, make it a capital E, but I would give you full credit. This is coming back to like Greek, and that's where it's coming from. So like technically speaking, yeah, it's wrong, but I would never like fault you for it. Okay. Is that okay? This is tricky stuff. It's weird. It's brand new. It's kind of wonky. I totally get it. Okay, let's try a couple of these. So let's look at A. I'm not going to do all of these. Let's just do A and C. So A, is there any restrictions on my X values here? No, X could be anything. Those arrows mean it's going wider. So remember, it's keeping with the general trend. So it's ever so slightly getting wider and wider and wider. So our domain is going to be X values such that X is an element of our real number system. So X can be anything. That's basically what we're saying. There is a limit on our range. What is the smallest Y value we can have? Good, -3. So here it's Y value such that Y has to be greater than or equal to -3. But after that, it could be any Y value. Oh, sorry. For C, this again is those arrow diagrams. Arrow diagrams are only ever used for discrete data. So here I could just list it. The possible X values I have are my first circle. Possible Y values are my second. So our domain here is just 1, 2, and 3. Oops. Our range is 2 and 6. For discrete data, you can write it like that, or you could put in the X values such that they're 1, 2, and 3. Both are accepted for discrete data. Sometimes it's nice just to be consistent and always put your variable such that, but both are fine. Go ahead, Andy. Yes. Honestly, I don't know. I think it's back in the day, mathematicians kind of decided it. Also, it helps differentiate between like ordered pairs in this. Same similar thing, like why do you indent your first paragraph? Like when you're writing like an essay, right? Like why do we do this? I don't know. It's kind of like our set things. Yeah. A little bit more clear. Yeah. Charlotte? I am not like, do I have neat printing? No. It should just be clearly a little bit wigglier versus like a smooth bracket. That's fine. Do your best. Okay. These questions are like the best questions for teachers to know if you understand this truly or not. So these are really good questions. This type of question, I can guarantee you right now is going to be on your test. So draw a graph of relation that has a domain where X is an element of the reals and a range where Y is less than or equal to 2 and has one X-intercept. It is hard. So there's a lot of pieces of information to include. So start off, draw your coordinates. Oh, that's unnecessarily large. Okay, so this graph can have any value for X. Let's put it in simple terms. Any value for X only crosses X-axis once and Y has to be equal to and less than 2. So let's put that on here first. So 1, 2, I have to have like a dot going through there. Nothing higher. So it has a maximum of 2 for my y values. Horizontally, it has to go as far in either direction horizontally and has to cross my x-axis. Are there lots of possibilities here? Totally. So make sure you're drawing it carefully. You could draw a graph like this. That would totally work. You could draw a graph. They have to have the arrows because my x values go on forever. So this would be like a plateau where it's saying it's equal to x that whole way. Or equal to, sorry, 2 that whole way. Go ahead, Andy. Mm-hmm. It has to hit that 2 line though, because it said equal to 2. Okay, only difference is now it wants 2 x-intercepts for the second part here. So now this is going to be like more of a parabola shape. So still maximum at 2, any x value, but crossing my x-axis twice. So question B is also a really good question that like math teacher loves it. Explain why it's not possible to draw a graph that has a domain of x as an element of the real. So x can be anything, but y is less than and equal to 2 and has no x-intercepts.
Well, because it's less than 2, which is above the x-axis, and it goes on forever, it would have to put the x-axis.
Good, right on. So if y is less than or equal to 2 and an element of the reals, that means it keeps going. So it keeps going into our negatives, which isn't possible unless it crosses 0 or the x-axis. Okay. So that's a lot of content today. We still have 20 minutes left in class, and you could go back and do some practice questions. You might want to start on the practice questions from lesson 4 if you're really feeling this right now, or you can go back. I'll scroll down so you can see what ones I've assigned, but that is what we're doing for the rest of the class today. It's a lot of new information, I know. This stuff is going to keep coming up, though, throughout the unit, so we're going to keep seeing it again and again and again. So for lesson 4, all you have to do is numbers 1, 2, and 6. 4, 1, I actually won't make you do all of them. Sorry, let me limit this a little bit more. Sorry, Mateo, what's that? Actually, today you could just like work with a partner, and because I don't think you have to draw. It's not as like cumbersome. Okay, so for 1, you have to do A and H. 2, I want you to do B, C, E, and G. I'm just making you not have to do so many. And then all of 6. 6 is just an A and a B. Okay, so that makes it a little bit less. Make sure you're circling those specific ones. If you're struggling, should you do more?
Yes.
Yes, you should.